Welcome back. We are discussing the lesson carbon compounds. In the previous session, we discussed about the two important properties of carbon due to which carbon forms millions of compounds. Catenation and tetravalency along with the small size of the carbon atom makes this possible. And we also saw how carbon, it forms a covalent bond with hydrogen atoms and produces the simplest carbon compound, methane. In this class, we will be discussing few more other compounds produced by carbon. Now, if we observe, methane has the chemical formula CH4, which means that one atom of carbon is covalently bonded to 4 atoms of hydrogen. By doing so, the valencies of carbon are satisfied. We know that carbon requires 4 valence electrons to become stable. So by sharing one electron pair each with hydrogen atom, the 4 valencies are satisfied and carbon is stable. And here carbon is bonded to hydrogen atoms. Therefore, such compounds are called as hydrocarbons. So, hydrocarbons are carbon compounds formed by the interaction between carbon and hydrogen only. So, these are compounds. To define it very in simple terms, hydrocarbons are compounds containing hydrogen and carbon only. Hydrogen and carbon only. So, in this class, we will be discussing some more hydrocarbons such as methane. Let us start the discussion by discussing the different types of hydrocarbons. Hydrocarbons in general are of 3 types. They are called as alkanes, alkene and alkyne. No need to be worried about the peculiar terms. The concept is very easy. So these are the 3 types of hydrocarbons. They contain only carbon and hydrogen. We will also discuss about how these compounds are formed. Alkanes, they are represented by the general formula CnH2n plus 2, where N is equal to the number of atoms. So, the importance of this formula is, by using this formula, we can write the structures of different alkanes. So, let us start with a simple example. Let us substitute N is equal to 1. So, if N is equals to 1, then it would be C1 and H 2 into 1 plus 2. That will give us the formula C 2 into 1 2 plus 2 4, CH4, which you know already. Its chemical name is methane. So hence we have derived at the first alkane, that is methane. So methane is the first member in the alkane family. Let us look at another example where N is equal to 2. If we substitute N by 2, then we will have the formula. If N is equals to 2, then it will be C2 and H 2 into 2 plus 2, which is equal to C2H, 2 into 2 4 plus 2 6. So we will have the formula C2H6. Let us write the structure of this particular compound and find out what is the name of this particular alkane. So, how to write structures of hydrocarbons? First step is write down the carbon atoms present. So, there are 2 carbon atoms present. Therefore, what we do is write down all the carbon atoms. All carbon atoms. Step number 1. How to write the structure of hydrocarbons. After writing all the carbon atoms in a straight line, so let us do that for this compound C2H6. So we have in a straight line 2 carbon atoms. Next, point number 2, join them with a single bond. With a single bond. So you know single bond is C bonded to C. Then add all hydrogen atoms. Add the hydrogen atoms. Now, addition of hydrogen atoms is done so that the valency of carbon is fully satisfied. Each carbon should be bonded to 4 atoms for filling the tetravalency nature. So, in such a way we have to add the hydrogen atoms. So, in this case, there are C2, 2 carbon atoms are already written. We need 6 hydrogen atoms for writing the structure. For this particular carbon, it is already bonded to 1 carbon. So, 1 valency is satisfied. It needs 3 more valencies. So, 1, 2 and 3. And fill it with hydrogen atoms. Therefore, we can see carbon is bonded to 4 atoms. 1, 2, 3, 4. So, this carbon is stable. It has got its valence electrons. Similarly, we do it for the second carbon atom also. We just fill in the hydrogen atoms. So, this structure is now ready for the formula C2H6. So, writing of structures is so very easy. All you have to do is write down all the carbon atoms in a straight line, join them using a bond, and finally add all the hydrogen atoms such that carbon should always be bonded to only 4, not less than 4, not more than 4. 1, 2, 3, 4. Similarly, 1, 2, 3, 4. Hence, this compound is stable. What is the name of this particular hydrocarbon? The name of this hydrocarbon is ethane. So, this was methane, this was ethane. So, is there any rule which has to be followed for naming the hydrocarbons? Yes, there is a very simple rule. So, let us write down the structure here. Name ethane. The first member is methane. So here N is the number of carbon atoms. N is the number of carbon atoms, and by using this formula we can come to know if there are 2 carbon atoms, how many hydrogen atoms to be added. If there are 3 carbon atoms, how many carbon atoms to be added. So let us quickly come back to the naming of hydrocarbons. What is the criteria to be followed when we are naming the hydrocarbons? So the naming is very simple. If there is one carbon atom present, then the name of the hydrocarbon, it begins with the word meth. If there is 2 carbon, the name begins with the eth. If there is 3 carbon, the name of the hydrocarbon starts with the word prop. 4 carbon, it starts with but. 5 carbon is pent. 6 carbon is hex. 7 carbon is hept. Similarly, 8 carbon will be oct, non and dec. So let us look at only the first 7 carbon atoms. We can keep on adding and the list goes on. As you know, the property of catenation, carbon can simply be forming large chains. So this is the criteria for naming the hydrocarbon. So apply this over here. You see, there is 1 carbon here, therefore the name starts with meth. If there is 2 carbon, the name will begin with eth. Then what is this ane? The ane refers to alkane. So alkanes have the property that these are hydrocarbons containing only single bond. Though these are alkanes. So define alkane. Alkanes are hydrocarbons containing single bond. So let us write few more examples for alkanes to prove this point that alkanes contain only single bond. So we have already written the structures for methane and ethane. Let us do it for propane. So for a hydrocarbon containing 3 carbon, then if it is an alkane, it will have the formula CnH2n plus 2. So let us replace N equal to 3. So there are 3 carbon atoms. If there are 3 carbon atoms, then how many hydrogen atoms should be there? So the formula is 2n plus 2. So 2 into n is equals to 3. Therefore, if there is 3 carbon atom, then there will be 8 hydrogen atoms according to the general formula of alkane. So C3H8 will be the chemical formula of the third alkane member. Let us write the structural formula. How to write the structure? As you know, first write down all the carbon atoms in a straight line. So there are 3 carbon atoms. All the 3 carbon atoms are written in a straight line. Point number 2, because it is an alkane, it will always contain single bond only. Therefore, the next job is to join all these carbon atoms with a single bond. One single bond, one single bond. And step number 3, add hydrogen atoms so that valency of carbon is 4. So let us begin with the first carbon atom. Say it needs 3 more valencies to be filled. So 1, 2, 3. 3 bonds and we add 3 hydrogen atoms. Look at carbon number 2. It is already bonded to 2 carbon. 1 carbon, second carbon, which means it needs 2 more valencies to be filled. Only 2. Therefore, this carbon can take 2 more hydrogen only. And like this carbon atom requires 3 more valencies to be filled. So we fill in the hydrogen atoms. Once we have written the structure, check for 2 important things. Whether carbon is bonded to 4 atoms, whether the valency of carbon is satisfied, and check whether the hydrogen atoms all are included. So there should be 8 hydrogen atoms. Let us check. 1, 2, 3, 4, 5, 6, 7, 8. And that is the structure of the alkane containing 3 carbon atom. So if there is 3 carbon atom, that alkane will have the name beginning with the prop, and because it is an alkane, the name will end with the ane. So propane. So the third member in the alkane family is called as a propane. So let us write down the structure. Propane. Let us write the structure of one more, and the structures of the remaining 3 you can write down and practice it. So the carbon atom, hydrocarbon containing 4 carbon atoms. So in examination, question will be something similar to this. An alkane contains 4 carbon atoms. An alkane contains 4 carbon atoms. So 2 things are clear. It is an alkane, which means it will have only single bond. Number 2, because it is an alkane, it will have the formula CnH2n plus 2. Write the chemical formula, structural formula, and name this compound is the question. So once you have the information that it is an alkane, your job is simple. There is 4 carbon atom. So 4 carbon atom means CnH2n plus 2, CnH2n plus 2. So the chemical formula of this alkane would be C4H10. So that is half mark, let us say. Next, you have to write the structural formula. So writing the structural formula is easy. Write down all the carbon atoms 1, 2, 3, 4 in a straight line. Then join them using single bond, because alkanes contain only single bond. Next, there should be 10 hydrogen atoms. So this carbon will contain 3 hydrogen atoms and the valency is 1, 2, 3, 4. Checked. This carbon is already bonded to 2 carbon, therefore it can take 2 more hydrogens. Similarly, this carbon is also bonded to 2 carbon, so it can take 2 more hydrogen atoms, and the last carbon is bonded to 1 carbon, it can take 3 more hydrogens. The structure is ready. Count the number of carbon 1, 2, 3, 4. Check whether carbon is bound to 4 atoms. In this case 1, 2, 3, 4. Done. This carbon is bonded to 1, 2, 3, 4. Done. 4 and 4. So the valency of of carbon is satisfied. And finally, count hydrogen atoms: 3, 5, 7, 10. So 10 hydrogen atoms are present. So your structure is correct. And what would be the name of this alkane? Because it contains 4 carbon, the name will begin with bute. It's not but, bute. Because it's an alkane, it will end with the ane. So answer is, the name of this 4 carbon containing alkane is butane. So we have written the structures of the first 4 alkane: methane, ethane, propane and butane. As a homework for practicing writing the structural formula and naming the hydrocarbon, you can practice these 3: carbon containing, hydrocarbon containing 5 carbon, containing 6 carbon, containing 7 carbon. Derive the formula, write the structural formula and name the alkane. What would be the name? Alkanes are saturated hydrocarbons. Is an example for saturated hydrocarbon. What do you mean by this? Saturated means completely occupied or completely filled to the limit, isn't it? So these are called as, alkanes are called as saturated hydrocarbon because the carbon is completely bound to 4 other atoms and all the valencies are filled, meaning no more hydrogen atom or any other atom could be added. Take the case of methane or any other alkane. The carbon is saturated with hydrogen atoms. It can take 4 atoms. It is already bound to 4 atoms, which means it cannot take any more, which means it is saturated. So saturated hydrocarbons are less reactive because they are already stable. The valencies are satisfied. So that is why the name saturated hydrocarbon. Example is alkane. So which is the first type of hydrocarbon that we have studied. Let us now look at alkenes and alkynes. What is the general formula of alkene and what are the different members of alkenes, and let us write down the structural formula of alkenes like we have done for alkanes. The naming will remain exactly same except for the fact that the alkanes will end with the ane, whereas alkenes they end with the ene. The name of the compound, it ends with the ene, E-N-E, whereas alkynes, their name ends with the yne, Y-N-E. So this is the last part of the name for alkene and alkyne. The other nomenclature is same. If there is 1 carbon atom, it will begin with the meth, 2 carbon will begin with the eth, 3 carbon will begin with the prop, 4 carbon will begin with the bute, and so on. So let us start the discussion about alkenes and alkynes.